Hi guys, and welcome to this video on areas of basic shapes. Darren here, Maffs Guru, really good to see you. Hopefully this is going to be a fun-filled experience. Well, maybe not, but we're going to do the areas of basic shapes. So we're going to look at, well, what did it mean by finding the area? And there are some interesting tricks in this. Be able to convert units of area, I'm going to leave that to the very end, and be able to find the areas of squares, rectangles, parallelograms, triangles, and composite shapes. Sounds like a lot of stuff to deal with, yes? Okay, so let's start with what is the area of a shape. Believe it or not, is the area what is inside. It's the space what is inside of a shape, in it. Like, I don't know why I've got that really strange accent, but if I was to draw, for example, our most wonderful of shapes here, and do not call that a square at this moment in time, because we do not know it's a square, all right? It is nothing more than a quadrilateral at this moment in time. By putting these little lines here, it makes it a lot closer to being a square, but we would also need to put our little right angles in the corner as well. Now, obviously, in that situation, it makes the diagram look a little bit confusing. So we are going to, at this moment in time, just go, well, look, this is a square, and the area is the stuff inside, right? That is the area. It is the space inside. Now, generally speaking, we will either shade them or not shade them. And shading stuff actually confuses the brain, believe it or not. When we shade things and give you a question that says find the perimeter, your brain goes, oh, it's coloured in, I'm going to give you the area instead. Doesn't matter that you know you've read the word perimeter, your brain goes, it's coloured in, it must want the space inside, it must want the area. All right, so we're looking for the space inside. And there we go, that's where area is. Now, if you want to have, if you go to maffsguru.com, all of these notes, everything I write on now, you can download. You can cut them up, stick them in your study book, write some more stuff all over them, and I suggest you rub the stuff all over it. So let's look at the area of basic shapes. So here, ladies and gentlemen, is, we will say, a square. Now, the thing we know about the square is all of the side lengths are exactly the same. And you'll notice that most maths teachers will go, oh, we'll call that L. All right, the problem with the letter L is it looks very similarly like a 1. So I'm not going to do that. I refuse. I'm going to break with convention, and I'm going to say, let's make the length of a side X. Right? I love the letter X. It's fabulous, fabulous, fabulous. Now, what that means is, to work out the area, the traditional way of doing it, you would write area is equal to X times X. Right? So what does that mean? You take the length and you multiply it by the height. That is certainly one way of doing it. I don't like thinking of it that way because when I give you a piece of paper, and I'm going to show you a wonderful piece of paper. This is my daughter's drawing of Shrek. She's coloured it in. That's not my colouring in. Don't be like that. Yes, at this moment in time, this could be what? The length, and that could be the height. But as soon as I turn this piece of paper around and cover my beautiful face, what's happened? Well, yeah, the length and the width all change. So I like to think of it in a different way. And I like to choose one right angle. And I choose that one right angle because when I zoom in really, really close, what I notice is at the end of that right angle are little arrowheads. And those little arrowheads are saying, choose me, choose me. So choose me. Basically, just choose the corner and multiply those two sides together. All right, so what does that actually mean? Let's put this back in order. Well, I'm going to take this side length here and that side length and multiply them together. Now you're going to turn around and say, well, hold on a moment, that's still the same. That's still X times X. It is. But it doesn't matter what shape I have now. So long as it's a quadrilateral, so let's draw another quadrilateral. This one here is obviously a rectangle. So I'm going to now change to have single little lines on there and double lines. They just say that the sides are the same length. But again, because it's a quadrilateral, it's a basic shape, and we love these basic shapes, I am going to draw a right angle there, he says, in the biggest orange pen ever. There is my right angle. I'm going to choose one of those right angles, and I'm going to use the sides that connect that right angle. And ka-ching, ladies and gentlemen, here we go. Now, obviously, the real mathematicians, not me, they might call that X, and then we have to give this a different letter, Y, for example, or, you know, they may call it length and width, right? So, you know, more traditional mathematicians will go, well, we'll call that length, and we'll call that width. Again, you change that away, it's no longer the length and width, it confuses people. So in this situation here, using the traditional, the area of that would be length times width. Again, I don't. That times that. Choose a corner. Thank you very much. So what other shapes did they say I was going to have to do with? Oh, triangles. I love triangles. All right, so here is a triangle. It is the most basic of shapes. Now, I'm going to show you what I do for the triangle. I do that times that, and I halve it. What do you notice the angle? What my arms, if I had a third arm, I'd be up here somewhere, looks like a triangle. This times this, and halve it. Now, lots of people turn around, you know, the traditional mathematician go, the reason we're halving it is because actually we have a square here. We have a square or a rectangle. So we've had the rectangle and then we halve it. Well, I don't care about that. Thank you very much. I'm just interested at this moment in time in going, okay, there is a rectangle. Is there a right angle? There is, it is there. I am now going to take those two sides. I'm going to multiply them together, and then I'm going to halve my result. So yeah, I'm going to divide it by 2. So let's assume here my triangle has the same length. Let's call that x again, and that would be x. So in this situation, the area would be equal to x times x. And then we would halve the result. Now we can either write that as a half times x times x. This is exactly the same as x times x all divided by 2, or later on x times x in brackets divided by 2. Now the reason we're going to put it in brackets is we know from bid maths, brackets must be done first. So we have to do the x times the x and then divide it by 2. All of these things can be done on a calculator. Now you won't have necessarily seen that. You'll have seen it in a different way, and I'll just draw a different triangle, well, same triangle. But again, it's more traditional in maths to call this one here the base and this one here the height. And you're probably going to say, well, the area here is equal to a half times the base times the height. And again, I'm just using the letter B for base and H for height. It's the same. Yes, if I look at my right angle in the corner here, I'm multiplying my base and my height. Now, how does maths try and trick you? It tricks you by drawing triangles in all sorts of different ways. So we may end up with a triangle looking like this, for example. And you're going to turn around and say, well, hold on a moment. And I'll go, yeah, okay, so where's the base and where's the height? And again, maths tries to trick you. So they may have that as 10. And they'll have that as 5, and they might have that at 7. Is there a height on there at this moment in time? And lots of people will go, yeah, 5. And I'll go, no, not 5. Why 5? And you'll go, and I'll go, exactly. When you go to the doctors and you get your height measured, your height is measured from the bottom, so in this situation, the base, and then vertically straight up. Right? So actually, my height is there. That is my height, from the bottom to the very top of that point. And if you're lucky, the question will tell you that type of stuff, right? It won't actually do it with a thick line. It may do it with a dotted line inside. And they may say 6 on there. Now, the reason I go straight up and horizontal is, what do you know is there? Oh my goodness, it's a right angle. And once again, what did I tell you to do? When you have the right angle, doof, doof, and because it's a triangle, you would then halve it. So in this situation, I would be using, that's my base and that's my height. And that right angle just helps me do it. There's another way they can try and do it. And what they can sometimes do is they do construction lines outside, and they'll actually do an arrow here and put the 6 outside. They may even put a little right angle to help you. That's the trick to the question, all right? Yes, here, the area is still a half times base times height, but we have to be very careful which one is the height. Yes, so that's the triangle. What else do we have? A parallelogram. All right, parallelogram. Parallelogram. Now again, if you notice, we've got the 2 little signs there, so that's my parallelogram. How do we find the area of this? I wonder how we'd find the area of this. Do we know a base length? Well, as it turns out, we actually do. Do I know the height of this? Well, again, as it's drawn on this diagram, not at this moment in time. But if you're lucky, they may do this. And they may extend that out, and they may do a little right angle, and they may say, well, this one here is 8 centimeters, and they may say that's 5 centimeters, and lo and behold, what do we notice? We notice that little right angle again. So the area of a parallelogram, because it's a quadrilateral, multiply those two together. So in this situation here, my area would be 8 times 5, which would give me 40. Now don't write 40 because that's not right. What would we have to write? We would have to write 40 centimeters and squared. Right, 40 centimeters squared. Why? Because our units of area are very, very important, right? So units are really important. And the floaty 2 tells us we are dealing with an area. So if we go back here, my area would be equal to 1/2 times the base, which was 10, times the height, which was 6. Now again, we can do these in lots of different ways. Half of 10 is 5. 5 times 6 gives me 30. Now, did they give me area? Sorry, did they give me units in this question? Nope. So guess what I do? I put units and then the floaty 2. It is so, so important. Now, to give myself a bit of room, what I'm actually going to do is I'm going to highlight all of this there, and then I'm just going to drag it down so that when you download these notes, life is good and easy for you. And again, we've got the basics here. Now, the last part of this particular introduction is about composite shapes. All right, so composite shapes, composite shapes. What is a composite shape? It's a shape made up of other shapes. That's literally all it is. So for example, I might have this particular shape. Now actually, that's the trapezium. And that actually has its own rules as well. All right, so that has its own formula, which is that plus that times that and halve it. That's a whole new discussion for another lesson. It's all like dancing, isn't it? All right, so here, composite shapes are shapes that are made up of other shapes. So if I was to draw a dotted line down here, what you would notice is I now have 2 basic shapes. I have a quadrilateral and I have a triangle. And what we would be able to do then to find the area of this whole thing is we would be able to find the area of this by doing that times that, because it's a quadrilateral. So I'd find a right angle and I'd work out the 2 sides I was going to multiply together. Then what I would do is I would then work out the area of my triangle. Yes, so my area of my triangle in there would be that times that and halve it. Again, we know that's a right angle there. So I could use that height and that length there. And then I would total by add them together. Right, so composite shapes are freaking awesome. But again, we can do them in other ways. We may actually have a shape such as this, where we have a square and we have a triangle inside it. And what they want us to do is find the area of the shaded section. Well, what we notice is we've got a quadrilateral that we know how to find the area of. We have a triangle inside, which seems to have been cut out. So whenever they cut a section out of the shape, all right, so when it's cut out, you subtract. And what do I mean by that? Well, here we added them together, all right, because we did them as 2 separate shapes that were part of a bigger shape. But in this situation, it appears that we have a quadrilateral, we have a triangle, but the triangle has been removed from the shape. So we have to cut it out, as I say here. And when you cut things out of the shape, you subtract them. But you still find the area of the whole quadrilateral, you find the area of the triangle, and job goes on. Right, let's look at some examples. All right, so the examples are very kindly from the Cambridge Essentials textbook series, because Cambridge very kindly allowed me to use them. So examples, what have we got here? We got this one. So we have a quadrilateral that is 6 centimeters by 2 centimeters, and it says find the area. Units are really important. What am I going to do? Well, I've got a right angle there. I know that I can do that times that, just choose 2 of the sides, and so my area is equal to 6 times 2, which is 12. Is that my final answer? No, and if you leave that, unfortunately, you're going to get it wrong. 12 centimeters and squared. And again, people go to me, why is it a floaty 2? Because you are dealing with 2 dimensions. So area is 2 dimensionals. You're also, in this situation, multiplying 2 lengths together, but we'll come back to that when we do algebra. Ka-ching! There is example number 1, nice and easy. And so for example number 2, notice what they tried to do here. They tried to trick you by drawing the parallelogram in a different orientation. So it's just in a different way. Okay, so how do we do this parallelogram? It's a quadrilateral. So what am I looking for? My right angle. I've got that one there and that one there connected by a right angle. Those are the ones I'm going to use. So my area here is given by 8 times 3, which is 8, 16, 24 meters with the floaty 2. And again, these to me are easy, beautiful, beautiful marks. All right, what have we got here? We have a triangle. Do we have a right angle? I should Coco, look at that. There's my right angle. It's connecting those 2 sides together, but because it's a triangle, that times that and halve it. So my area here is going to be 1/2 times my base of 13 times my height of 7. Now I do not know my 13 times 7 table. So what I'm actually going to do is fire up my calculator. Now you'll see the calculator in the top, oh goodness gracious, left or right hand side of the screen. I don't know which side I'm on, but it's on the top corner. We'll leave it there. So what am I going to do? Well, I can do 1/2. So your calculators might not look like this, ladies and gentlemen. Don't worry about it. It's going to be 1/2 times 13 times 7. And there we get 45.5 meters and squared. And realistically, guys, it doesn't get any more complicated than that. All right, let's do some composite shape examples. Example 4. Okay, so this is a composite shape and they want us to find the area. I'm going to shade it in this particular example. It wasn't shaded in the textbook, but I want to find that area there. Now, what you've got to do, remember, is look for shapes inside of shapes. We're either adding shapes on or taking shapes away. So what are we doing in this situation here? Well, I seem to have a rectangle and a triangle. So I'm going to find the area of the rectangle first, or the quadrilateral. And we know that that's got a right angle in the corner there. So I'm going to do that times that. There we go. So that's going to give me the area of that, which is going to be 10 times, well, we know these 2 heights here are the same. That height there and that height there are the same. So it's 6, which gives me 60 meters squared. Ka-ching, thank you very much. How do we find the area of the triangle? We use the idea of the formula. Area of the triangle is equal to, there's my triangle, so base times height and halve it. Right, what's the base of my triangle? Well, my triangle, I always tend to draw it again. I want to be able to see my triangle because I know the diagram's there to help me, but I can add lines. So where is the base of that triangle? Well, it's going to be there. They've drawn it the other way around, but we see a right angle, and there we go there. So I now know the area is 1/2 times the base. Well, the base, this length here, is the same as this length here, which is 10. Times the height they've given me here of 4. I can do these in my head because I know that 1/2 of 10 is 5 times the 4, and 5 times 4 is 20. And don't forget the units, 20 meters squared. Am I done? Nope, because if you remember, we've got to now subtract them because they've cut that rectangle away. So therefore, my area is going to be the bigger one. So 60 meters squared minus 20 meters squared, which gives me 40 meters squared. And all that working out, believe it or not, is required in a maths exam or maths test. I think that's it for there. Right, let's move on to the next section, which is converting units of measurement or area. When we convert units of area, if you remember, we have millimeters, centimeters, meters, and kilometers. Now, the way we do this conversion is, if you remember, we know the basics of converting between each of these individual units. All right, you should know how many centimeters there are in a meter, how many millimeters there are in a centimeter. So to go from centimeters to millimeters, we know that ordinarily we times by 10. From meters to centimeters, we times by 100. And from kilometers to meters, we times by 1,000. This is ordinarily, this is not area at the moment, guys. And we would do the opposite. when we go the other way around. So there we are, converting units. But this is only for length. Now, what we tend to notice, and I'm going to show you a quick example here, is if I was to have a square that is 1 centimeter by 1 centimeter, the area of that is equal to 1 centimeter squared. Ka-ching. But we know that that can also be written as 10 millimeters by 10 millimeters. And the area in this situation would be 10 times 10, which would be 100 millimeters squared. But we know that this shape here and this shape here are identical. We've just changed the units. So we now know that we have a way of converting by saying, well, 1 centimeter squared is equal to 100 millimeters squared. So what we've actually done is we've multiplied by 100. So to go from centimeters squared, so now I'm going to start adding the squareds on, because these are my units. To go from centimeters squared to millimeters squared, I actually times by 100. Now that's 10 times 10. So I'm now going to put a 0 on here, which means I must divide by 100 to go the other way around. Can you see what's going to happen with meters to centimeters? Well, we're going to times by 100 in one way and times by 100 in another way. So actually, we're going to end up with 10,000 going that way, right? Because we're doing 100 times 100, which is 10,000. And when we've got 3 zeros, so from kilometers squared to meters squared, there's 1,000, which we times twice. So it actually turns into 1 million. Now later on, we're going to write that in a different way using floaty numbers and index notation. But converting units of areas basically is using that diagram there. So let's have a look at some examples. And 0.248 meters squared, I want to convert it into centimeters squared. Oh my goodness. Meters squared into centimeters squared. Hold on a moment. We know following the arrow, that's going to be times by 10,000. So we need to do 0.248 times 10,000. I know that when I multiply, I move my decimal point to the right, and I know that I move it by that many places. And because I got 4 zeros, I am going to bounce it 1, 2, 3, and over a missing number. So there's the 2, 4, and 8, and it's jumped over nothing. And so I now know that that is going to equal 2,480 centimeters squared. Now, if you're not sure about the whole bouncing decimals thing, I've got videos on it, but it's really, really important. And a final example, let's turn 3,100 millimeters squared into centimeters squared. So scrolling up, millimeters squared into centimeters squared, you are going to divide by 100. Okie dokie. So 3,100 divided by 100. When I divide, I move my decimal point that way. I divide, I'm going to bounce it by 2 places because the 2 zeros. So there is my decimal point. 1, 2 that way is going to put it between there. So that's going to give me 31.00 centimeters squared. Do I need the 0.00 at the end? No, I don't. So in fact, I can just write that as 31 centimeters and squared. And there we go. We're done for this lesson. Thank you very much for watching. All of these notes are downloadable from mathsguru.com. Examples, thank you very much, Cambridge. Look after yourself. Hopefully I'll see you in another video. Take care, guys. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.